Now we are looking at a very important aspect of software engineering, that is user interface design. So there are various types of user interface or user interface designing. First is user interface has three categories. They can be divided into three main categories. First is your command line based interface. Might have seen Windows user with black screen, or in Unix blue screen. These are command line based interfaces. Then you have menu based or menu driven interfaces, where you have various menus, and on the basis of menu different functionality are invoked. And then you have direct manipulation interface. So these are three types of user interfaces, and each category which I just discussed of interface has its own advantages and disadvantages. And I would say one more thing, that each category is employed for some or the other specific execution of work or job. Modern applications, support a combination of all these three types of interfaces. You will find menu inside, or you can say there's a command line inside your menu, or you can have the other one, that is the third one, direct manipulation inside your menu base. So there may be a combination of these three type of interfaces. People are using it as and when required. Then choice of interface, which interface you're going to choose, or what are the aspects you're going to view at. So which parts of the interface should be implemented using what type of interface, right? There are no simple guidelines. I must say that the guidelines, there are guidelines, but they're not so simple. And to a greater extent, it actually depends on the experience and discretion, style, intuitiveness, understanding of the designer. It also has a study of characteristics of different interfaces that would give you or us some idea. Let us start with command language based interface. In this command based interface, the name is suggesting that it is going to incorporate some language to form commands. And we have user frames that would require commands in a certain language, and you need to type them in wherever it is required. Like in Windows, when you want to find out the MAC ID of your machine, then what you would type? You would type ipconfig. You want to change the directory, you type cd. So simple command language interface, how you're going to design this command language interface. First, to determine all the commands you'll be needing that to be supported, and you're going to assign unique names to different commands, because it should not match with the system commands, and it should be easily understandable, readable, and memorizable. A more sophisticated command language interface, which would allow users to compose primitive commands, and that may form some complex commands. For example, cat x.dat and grep123. So you are combining this one with grep123. You don't have to worry about what these are. Just understand that this is your command and you're trying to combine them. So these kind of this idea of combining them or composing primitive commands to make a more complex command is what makes a good design, just like a programming language. So the facility to compose commands, it reduces the number of command name users would have to remember. As I said, you have to memorize it. You have to remember them. And even if you forget one letter or character, that command is not going to work. So command can be made concise. You don't want user to type long commands, although he may not remember or he may commit mistakes. And also to allow faster interaction with the computer. And you simplify this input complex commands, because the commands you are inputting, they may be complex, but you may simplify it. What are the advantages of command language interfaces? First and foremost is easy to develop. Compiler writing techniques are now well developed, well understood, and widely available. Then it can be implemented even on a cheap alphanumeric terminals. You don't need to have a gigantic system. You can have them implemented even in simple terminals, and they are more efficient compared to the other type of interfaces that we are discussing today. But what are the disadvantages of command language interfaces? First, it is quite difficult to learn. You need to memorize primitive commands. If you don't memorize, you have to keep them somewhere, or you have to go to help every time. And the user is supposed to type the command. Now, those users who have crossed 40, uh, working in this industry, software industry for quite long, they would not. It will not be a good idea for them to type because there are various things which are coming up as with respect to the health concern. So the disadvantage is you are required to type the commands, and then again, as I suggested, when you type, you make mistake, and formulating commands in the command language, typing them in, you can land up with certain errors. And the interactions are only through one screen, that is the keyboard. You cannot use, or the advantage of mouse cannot be incorporated. And for casual and inexperienced user, it is not suitable. For more experienced, more versatile and knowledgeable users, this may be good, not for those who are just naive. But there are issues with designing a command language interface. First is it involves several issues. First, the designer has to decide he has to decide the mnemonics that are to be used for the commands. He has to see what means what. He has to give the user a command to type in. So what we call them is the mnemonics. And mnemonics needs to be meaningful. For change directory, you may write cd. Can you write xyz? XYZ? No, because this is not meaningful. But to be concise, to minimize the amount of typing required, it has to be concise as well as meaningful. So the designer has the discretion whether user will be allowed to redefine command name to suit their own preferences. If you have a command of say 10 characters, is it possible that the user may redefine it with 3 say letters? So letting a user define his own mnemonics for various commands is a quite amazing feature, useful I must say. But again, it will lead to complex, or it will increase the complexity of your user interface development. Designer again has to decide whether it should be possible to compose primitive commands for creating more complex commands. The syntax and semantics of command composition option is to be clearly and unambiguously means there has to be no confusion. The command should be so clear that if a naive user is also learning or understanding, he must be able to do the work. For example, I just said that ipconfig. This is a command, or this is a command line operation in Windows. Now this is so versatile and it is so numerically correct that anybody can understand and he will remember it for long. Right? Then the ability to combine command is a powerful facility for those users who are experienced, but not very good for inexperienced users. Now, let us turn our attention to menu-based interface and the advantages of menu-based over command line interface. First of all, users are not required to remember exact command names, and typing effort is 0 to minimum. And menu selections, they use a pointing device, which I'm using right now. This is mouse, and the factor becomes very important for the occasional users who are not well versed with typing. For experienced users, the menu interface is slower than command language interface. He has to press, he has to go to various component and click and then wait. So all these things, experienced user, they are good at typing. So for them, it may be a concern. And also get speed advantage by just composing simple commands into complex commands for experienced user. And the composition of command in a menu-based interface is not possible. So the actions which involve logical connectives like and, or, all, awkward to specify in, or difficult or not even possible in menu-based system. But there are programming which controls this menu, where you can have these connectives, but in a different concern. So if the numbers of choice is large, it is difficult to design a menu-based interface. And even this moderate size software, they would need hundreds and thousands of menu choices, even a basic software. So a major problem with this menu-based interface is to structure large number of menu choices to make it manageable, to make it worthwhile. Then structuring menu interface. There are various options which may be adopted to structure menu items. First is you can have walking menu, then scrolling menu, and then hierarchical menu. Scrolling menu. What is this? Scrolling menu. This is employed when the menu options are highly related. For example, text height selection in word processing software. This is scrolling menu. And scrolling menu items, it lets the user to view and select the menu items that cannot be accommodated on one screen. So you need to have scrolling menu items. You have to choose various options, but in a single menu or single screen, it may not be possible. For that, you have scrolling menu. What about walking menu? This is employed to structure large menu list, walking menu. So when any menu item is selected, it causes further menu item to be displayed adjacent to it in a submenu. Like you have this menu and you choose an item from here. When you choose item, there will be another menu. Then if you choose one from here, there will be another menu. This type of menu, they are known as walking menu. So these are submenus. So walking menu can successfully structure command, but there is a condition that there are tens rather than hundreds of choices. Then it is okay. And each adjacently displayed menu, it will take some screen space. So, but the total screen area is, after all, limited to us. Then we come to hierarchical menu. Menu items are organized in hierarchy or tree structure. So when we select a menu item, it will cause the current menu display to be replaced by another submenu. The submenu will be shown and the current menu will be hidden or maybe replaced. So one can consider this menu and its various submenu to form a hierarchical tree structure. So walking menu are a form of hierarchical menu only, and it is only practicable or practically viable when the tree is shallow, that is not large. And this hierarchical menu can be used to manage not shallow but large number of choices. But again, user would face navigational problems and he may or she may lose track of where they are in the menu tree, right? Then we have direct manipulation interface, the third category we started with. It presents information to the user as visual models or objects, and actions can be performed on these visual representation of the objects. Just you can put an icon representing a file into an icon representing a trash box for deleting the file. So here the direct manipulation is happening. And direct manipulation interface, they are known or in another name they can be termed as iconic interfaces. Iconic interfaces. So direct manipulation iconic interfaces, there are various advantages. Icons can be recognized very easily because icon is an image and a picture worth 10,000 words. And icons are language independent. Again, they are not depending on not concentrated to only certain language. They are language independent. But experienced user consider direct manipulation interfaces. They consider it to be slow, but naive user may find it quite worthwhile. So it is difficult to form complex command using your direct manipulation interface. Just for an instance, if you have to drag a file icon into a trash box, that is a recycle bin box, or deleting a file. So in order to delete all files in the directory, one has to perform this operation again and again. But you can easily do or perform this activity in command language interface just by typing delete star. This is where the command line interface overpowers the direct manipulation interface. Then let us talk about windowing systems. Most modern GUIs or graphical user interfaces, they are developed using some windowing system. What are these windowing systems? This can generate displays through a set of windows. And since we have this window as a basic entity in such a GUI, we need to first discuss what exactly a window is. So window. This is a rectangular area on the screen. Windows, if you are using Windows, then the window you show or you see or you interact with, they are windows only. And this is a virtual screen and it will provide you with an interface for carrying out some independent activities. And one window can be used for editing a program. You can have another window that will work as drawing pictures. And you can also divide a window in certain parts. You can have a client part and a non-client part. So a client area makes up whole of the window. So let me change it. This is the client part. This is the non-client part, right? So except for borders and scroll bars, client area makes up the whole of the window. And this client area is now available to us, means the programmer or software people. But the non-client area is under the control of window manager. Then this window management system, GUI might consist of large number of windows. So this is necessary to have a systematic way to manage the window. So we can have how to manage this windows in a systematic or planned manner. For that we have window management system, WMS. GUIs are developed using a window management system, WMS. What is this WMS? Is actually a type of resource manager only, and it will keep track of screen area resources, and it is going to assign or allocate different windows which are using the screen. So you have a window management system, and if you see in general terms in a wider perspective, a WMS can be considered as nothing but UIMS or user interface management system, and it has not only it does not is only concentrated to resource management, but it also provides the basic behavior to Windows, and it also provides several utility routines to the application program for user interface development. This WMS simplifies the task of a GUI designer to a great extent. First, to provide the basic behavior of the various windows, such as you can move, resize, iconify, and various other activities you can apply. Then it also provides functions or routines that you can apply to manipulate window, like creation, destroying, changing attribute of the windows, and drawing text lines. So a WMS consists of two major parts, a window manager and a window system. So window manager, this WMS has a window manager and a window system. User interact with your window manager to do various window related operation. For example, window repositioning, window closing, resizing, iconification, etc. And window manager also controls the screen real estate policy. Quite interesting stuff. So this window manager is built on the top of window system. So it makes use of basic services which are provided by your window system only. And this window manager, it determines how the window is going to be shown, or also the behavior. So the look and feel and the actions, the window manager is going to decide. So there are various kinds of window manager that can be based on same windowing system. Window manager can also be considered to be a specific or a special program. And this is going to make use of services, for example, function calls of the window system. We have application programs that are going to invoke window system for user interface related functions. So this window system, it is going to provide a large number of routines for the program. And it becomes very cumbersome, difficult to use these large set of routines. And most WMS, they provide a high level abstraction, which we call as widgets. Widgets are nothing but the high level abstraction of WMS. So a widget is actually the short form of window object. Widget. So widget. This is a short form of window object. So widgets are basic building blocks of your interface design. And we know that what is an object? It is a collection of related data with certain operations which are defined on these data. This object is similar to object-oriented paradigm objects. So this widget, the data of an widget object are actually the geometrical attributes such as size, location, placing, and it will have other attributes such as background and foreground color, etc. And you have operations on them like closing, resizing, moving, drawing, etc. What are the advantages of widgets then? First is it is used, or the reason to use widget as basic building block is that it will provide you consistency. And consistent user interface, they are going to improve the user's productivity, and of course it will increase the performance with as few errors as you can think. And this widget make users familiar with standard ways of using an interface. Users can easily extend their knowledge of interface of one application to some other application. Also, the understanding or the realization of for the users, they are greatly reduced. So we will try to identify standard widgets using the design GUIs in later section. But what we have seen today is user interface is an important component of any software product. We first discussed some important aspects which are associated with user design, interface design, and we also discussed desirable properties of a good user interface. So there are three types of interface we have discussed in length. First is command language interface, menu-based interface, and then iconic interface. And each type of these interface will have some advantages and disadvantages. But the most modern interfaces, they try to cover or combine these three as and when required. And finally, we discuss concepts which are associated with our window management system, which is consisting of two parts, that is window manager and window system. And we also discussed the use of widgets as the basic building block of GUI design. Widget is nothing but window object. So thank you so much. We'll be taking in detail this widgets in the later section. Thank you.